Hello everyone, this is Gautami from Sri Venkateshwara College of Engineering. Today we'll talk about a topic from DAO analysis of design and algorithm, and that we'll be discussing about the selection sorting. So introduction to selection sorting. Selection sorting is a simple and an intuitive sorting algorithm. It works by repeatedly selecting the smallest or the largest element from the unsorted portion of the array. This algorithm is not the most efficient, but it is easy to understand and implement. So in the selection sorting, we will be taking one of the first element as the min index and then we'll be comparing to it. So this is not said to be the most effective, but it is very easy and it is very easy to be implemented too. So as in this diagram, we can see that in the step 0, as we can see, the comparison will be done between the first element will be compared to the second element, followed by the second element to the third element, and the third element to the next element. As you can see here, when usually while comparing, when the third element, which is 10, which has been lesser than 15, and the comparison is done to the next element. So, and then later on, the one which is having the minimum will be swapped to the first one. In this case, as the comparison was done, initially the minimum was 12, then later on it was 10, then later it was 10. Again, when it was compared to 2, the minimum has become to 2. And so as all the comparison has been done, the 2 will be shifted to the first position. In the same way, it will be continuously done until it goes to all the iterations. Algorithm steps. First, mark the first element as the minimum. Next, compare this minimum with other element in the array to find the actual minimum. Finally, swap the found minimum with the first element and repeat for the rest of the array. What is the time complexity of the sorting? The time complexity of selection sort is big O n squared in the average and the worst case. This is due to the nested loop that transfers the array multiple times. It performs as well on the small database but becomes inefficient with a larger array. As we can see, the time complexity is n squared, which is linear, and the performances will decrease as the number of data or as the number of array elements which has been increasing. The performance of the sorting algorithm can be seen as decreasing. So in the best and the worst, in the worst and the average case, the algorithm complexity, the time complexity is seen as big O n square. What is the space complexity? Selection sort has a space complexity of big O1. It is an in-pace sorting algorithm, meaning it requires no additional storage. This makes it ideal for an environment with limited memory and availability. So this doesn't require any extra storage because as the minimum value will be keep changing during the iterations, and there is no need of separation storing. For every iteration, there is no need to store and separate minimum value in it, as we'll be replacing the old storage minimum value with a new one. The stability of the algorithm. Selection sorting is not a stable sorting algorithm. Stability in sorting means that equal elements maintaining their relevant order or after sorting. In selection sorting, equal elements may not retain their original order. So we can see that in selection sorting, we may say that the elements may not retain in their original order. So as we can see here, this is not stable in that case, as we will be considering the first element as a minimum and then start at comparing with the rest of the element, where that element comparably is lesser, then that will be taken as the minimum element. What is the practical application of selection sorting? Selection sorting is often used in situations where memory usually is critical. It is also useful for small data sets where simplicity is more important than efficiency. Additionally, it can be a good teaching tool for understanding the basic sorting concept. As we know that the selection sorting is one of the easier and easy to be implemented. But one of the major drawback is that it is only applicable and performs more better than with a small array. Comparison with other sorting. Unlike bubble sort, selection sort performs fewer swaps which can be beneficial. However, it is generally slower than more advanced algorithm like quicksort or merge sort. Understanding selection sort helps in grasping the principles of more complex algorithm. So in the case of bubble sort, we know that every element will be compared with each of the everyone and then will be later on sorted. So which takes more number of swapping and more number of comparison comparing to the selection sort. The bubble sort has more number of comparison. So we can see that the selection sort will reduce the amount of time which is being used, but it is not more efficiency as we have few more advanced algorithms like quicksort and merge sort too. So this is a pseudo code for the selection sort where we can see that there are two for loops used here. One is used to start the comparison with the one element which will be fixed and which will be later on compared with the other elements. So, and we can see that the minimum element, which is minimum, will be stored in the minimum indexed. And later on, all iteration will be swapping it with the indexer, the first element or the iteration which is going on with the element which has been smaller in that iteration. Conclusion, selection sorting is a straightforward algorithm that is easy to implement. While it is not the most efficient or large database, it offers educational value. Understanding selection sort lays the foundation for learning more complex sorting methods. So this was all about selection sorting. We came across this pseudocode. We saw how it has been implemented. We saw how it works. What is the complexity? What are the drawbacks of it? What are the advantage or what are the applications? So this was a small video about the selection sorting. I hope it was useful. Thank you for watching the video.